So thank you all for being here today. I'm sort of last, and this is a great opportunity for me to talk through some ideas that I've been playing with over the last several years. This project is the culmination of some conversations that I've had with all the people listed here, Dr. Clark, Julia, Jean-Luc, who unfortunately is not here, Bayra. This question of how is it that we can get more information about how people are using the landscape, especially in this sort of transitionary period between hunting and gathering and pastoralism, on the basis of the very few raw materials or materials that we have archaeologically at these sites, right? So how is it that we can get at patterns of mobility from the remnants of material culture available to us on the surface? So for the most part, archaeologists end up identifying or attributing seasonality of site occupation because of a couple of lines of evidence. So faunal analysis is very important, right? The age of animals, what animals are there. Lithics as well are often used as a tool for identifying seasonality of a site, what kinds of tools are being produced relating to the kinds of activities, processing activities, hunting that people are doing there. And then finally, seeds or pollen, the remnants of what people are eating, which is obviously very tied to seasonality as well. So what I, however, am most interested in is dealing with a class of material culture that exists in some parts of Mongolia pretty frequently, and that's ceramics. And one of the reasons why ceramics are a particularly compelling source of material culture for these questions is that they can be sort of dated based on the style, temper, material, shape of the sherds that we find. So we are able to, unlike stone tools can be a little bit tricky, we might not be able to tell what time period a particular projectile point is from. Pottery changes stylistically, and so therefore it is pretty useful in sort of attributing general time phase of occupation of a site. And if we could be able to identify when people are living at these sites based on ceramics, that would be a huge tool in helping us better understand changes in landscape use through time, movement, mobility on the landscape. So how does pottery relate to actual landscape use? The sort of first obvious answer to this is that you're using raw materials on a landscape. Just as you would use animals, you would use stone, right? People need to go to places to acquire clays. And those clays have chemical signatures that are characteristic of certain places in the landscape. In addition, there are other sort of pressing matters, factors that impact when and how pottery can be produced. So the availability of fuel for firing pots, as well as the time required to let pots dry sufficiently prior to firing. I don't know if you've ever tried firing pottery before, but if it's wet when you fire, it explodes, which is fun, but not really productive. And then finally, when do you expect to be able to use the pottery? Right? So in Mongolia, it's kind of a neat test case where the ground is fairly frozen in the winter. It's really hard to collect clay. So it would seem that the easiest time to collect clay and make pots would be the summer, also when there's a lot more fuel available to you. But especially in high northern latitudes, you're really going to get a lot of benefit from cooking pots in the winter months when there's not a whole lot of fat in your diet. So having a pot like this, a ceramic pot, allows you to slow boil things like bones to extract the grease that's in the bone. So you can sort of, when you have a fairly lean meat diet in the winter, this adds fat to the food without which you would die or sort of be fairly malnourished. So it would seem that ceramics would be especially easy to make in the summer and yet most useful to people in the winter. So this timing also sort of we can integrate in studying how people might have been planning on using and making pots and where they end up on the landscape. What I am using is what's called pXRF, Portable X-ray Fluorescence Spectroscopy. It looks like a laser gun. And essentially that's what it does. You press a button, it shoots a laser. It's non-destructive, and you sort of irradiate a sample. Now what's happening when you are irradiating the sample is these X-rays are photons, right? And this beam of photon is they interact with the atoms in your sample. They knock out electrons in the lower orbits of atoms, right here. And when they do so, the balance of the atom is out of alignment. And so there are electrons from the outer shells, the outer orbitals, that have to fill in the gaps in these central orbitals. And what happens when you do that is that these electrons require a lot more energy to stay around the atom. And so when they drop to a lower orbit, they have to lose energy. That energy sort of comes off as light. That's the fluorescence part. So what this machine does is it measures the particular light waves that are emitted after these photons hit these atoms, and it creates characteristic peaks, spectral peaks. Right? So then we're able to read these spectral peaks and essentially come up with a calibration that tells us what is the abundance of these atoms in a sample, right? Which tells us the composition of this sample in chemical terms. I'm going to just stop. Does anyone have questions about that? Because this is sort of, you don't need to know all the details of it, but if there's something unclear, yes?
Are you doing this to date the pottery, or what information?
This does not date the pottery. So what this does is it tells me what types of clay is being used and raw materials are being used. So we can then theoretically use that information to look at differences in pottery from different periods, different sites, and then eventually hopefully to tie it to places on the landscape. So say, oh, the clay over there is what was used for this assemblage of ceramics. Mm-hmm. All right. So why pXRF? There are some positives and people say some negatives about using this technology, especially for archaeological ceramics. I'm going to sort of an optimist, so I'm going to start with the positives. It's portable. It's in the name. You can bring it to the field. In fact, we've done this several times. It's small, yay big. You carry it with you, and you can actually just sit down. You can use a battery, and you can actually do this analysis in the field. It takes a matter of seconds, minutes to run. It's not destructive. You can use it destructively, but it itself does not require any sort of drilling or breaking of pottery sherds at all. So it's really great for museum applications as well. Yes?
When you use that tool, how you detect that fluorescence? Because usually it is very difficult, but you still need to go to a dark place to shoot?
No, you don't need to be in a dark place at all. It's a very high intensity beam, and so the darkness doesn't really matter. What you should be doing is covering, actually, because they're tiny bits of X-rays that are not actually dangerous, but the manufacturer makes us say that they're dangerous. It's not really. But light or dark doesn't matter. You can run it any conditions. Mm-hmm. It's a low cost per specimen. So unlike some analyses of ceramics through the INAA or something that are very costly, hundreds of dollars per specimen, and you can collect your data very quickly. So you have immediate retention of data from what you're doing in the field. So I know people who have integrated pXRF analysis into their sort of basic field cleaning and collection protocol. They figured out that it takes 5 seconds of analysis to get them a reliable read for their area. So they just they get sherds from the field, it's washed, they stick it on the pXRF, and then they have that data. So it can be integrated with some careful thought about how it fits in to a broader sort of research protocol. Finally, the newer portable X-ray fluorescence machines are very sensitive. This has been a critique of this instrument in the past, that the portable versions were not so great as the big lab versions that you could have in a sort of a nice fancy lab. Now, as with most technology, things have gotten smaller and better, so that the capabilities of this particular instrument are in the very low parts per billion concentrations of different elements. So it's very sensitive and accurate as well. All right, some of the stated critiques of this method related to that the older versions are less sensitive, it wasn't quite so good, especially with materials like pottery, that are not homogeneous, right? So that there's inclusions, there's clay, there's also just stuff mixed in there. What exactly are you getting? That, to me, is actually not a big problem. I am interested in the process of clay paste production, meaning what is it? Is it the clay, the sort of natural inclusions, any sort of tempering agents that potters are using to make a vessel? Those are choices. So in my mind, what I'm interested in seeing is the sort of sum total set of choices that potters have made in using sorts of resources. Mm-hmm.
How much does one of those gizmos cost?
They cost $40,000 to $50,000.
Oh,
So a lot of institutions will sponsor it. And a lot of actually geology departments have these. And so I found one at Columbia that I could borrow. So that's sort of sharing is caring. You can convince people to get one. It's great. Because once that's done, you're not sending things out for analysis. You have the whole machine. You take it. You can use it for several applications. There is a little bit of a sense that the sellers make this so easy sounding. It's sort of like a point and shoot camera that you just click and go and it tells you anything, right? These are used for scrap metal yards often, and that should be easy. You should have someone pointing to metal and saying, yes, that's iron of this grade or whatever. This is steel of whatever grade. But it's not rocket science, right? This is something that with careful thought, consideration, we can use this data very easily, and it is very good data. You just need to know what it is that you have and what the limitations of that data are. The final thing, and this is something that I'm working on right now, and hopefully with some raw resource material surveys, we need to create a calibration that is specific to the geology of Mongolia. So what is the signature of sort of basaltic rocks or very mafic rocks, right? Where is that range? It's pretty good as calibrated, but we can make it really good by using samples from survey and archaeological work in Mongolia itself. So that's all the background that I want to give you. I'm going to talk a little bit about the results that I have of a preliminary research project. And I'm mostly interested because this question of mobility, seasonal use of campsites is sort of the core of what I'm trying to get to here. I'm going to talk about 3 dimensions of my analysis. And those are questions of regionality. Are there differences regionally speaking in the composition of clays, raw materials used in making pottery? Can we distinguish those with pXRF? Second is seasonality. Are there differences in assemblages of ceramics at summer camps and at winter camps? Right? Because presumably people might be using different sets of resources at those places. And finally, temporality. Do we see changes through time at the same sites of ceramic assemblages? So a little bit of information. I used a set of sort of different sets of data to get this together. I collected this summer. My interest in regionality, are archaeological ceramics recovered from different regions of Mongolia? Are they compositionally distinct? Sort of a basic question. What this research might give us sort of a handle on are ranges and scales of movements, seasonal movements. Do sort of broad regions have similar sort of compositional types of pottery? Can you track movements of people through different regions? Changes in sort of resource use. What sources of clay? Obviously, there are lots of sources of clay on the landscape, but which ones are people choosing to use? And also, this sort of regional perspective has a lot of potential for comparative studies of ceramics in Mongolia more broadly. So this sort of question is, can we do that kind of work? So for today, I'm talking about a pilot sample of sherds from 3 different sites in Mongolia so Soyo from Julia and Bayra involved with all of this. 34 sherds from Soyo, which is a deeply stratified site that has a lot of sort of Neolithic-ish or whatever pre-Bronze Age occupation through Bronze Age and Iron Age. Hanoi Valley, where Jean-Luc has identified different seasonal sites. And then Dunhangai, which Jean-Luc was supposed to talk about today. And I'm not really going to talk about that. It's another deeply stratified site. But because he's not here to talk about it, I don't want to step on his toes. So that'll come out in a future version of this. But for this regionality study, I compared broadly the signature of these 3 sherds from these 3 regions. The seasonality then, again, can you use ceramic composition variability in certain campsites to look at differences in landscape use different times of the year? And for this, I focused on Jean-Luc's survey because he was able, this was for his dissertation, he was able to identify seasonal occupation at these sites. So I compared a sample of sherds listed here from 2 winter occupied sites and 1 summer occupied site, right? And the final thing that I'm going to look at is this issue of temporality. So can you actually see in the few deeply deposited, deeply stratified sites that are being excavated and have been found in Mongolia, can you identify changes in landscape use, resource use through time, potentially relating to shifts from more of a hunting and gathering and foraging and fishing lifestyle to one that's focused on pastoralism. So with that, you're making new seasonal rounds, you might be using new clay sources, which would then impact the ceramic compositional signatures of the sherds that you have. All right. And so again, that I'm using sherds from that Julie and Bayer had excavated at Soyo, deeply stratified site. And here are sort of the number of sherds. I'm really going to be focusing on these earlier sherds. I only took 4 sherds that were Xiongnu period, and that will relate a little bit more to the Zunhangai work that Jean-Luc has been doing. This is an example of the pXRF in action, a setup that can be either in sort of a lab situation or in the field. In case you're curious, this is a Bruker Tracer 5. We used a sort of a geo-exploration calibration that runs 3 separate cycles to highlight different phases of the spectrum, of the sort of various spectrum, and identify different types of elements, sort of very heavy elements versus lighter elements, rare earths and such. Again, the sample is a pilot study, so this is as random as I could get, but really just trying to feel out the boundaries of using this technique for answering these kind of questions. And I did take 3 readings per specimen to try and get around this problem of the non-homogeneity of the material, right? So to come up with a bulk chemical characterization of the sherd that I was analyzing. All right, this is the part that we're really more excited about. Results. So first, are there regional differences in ceramic composition? I'm going to throw up some results of a principal components analysis on here. The real thing that I want to emphasize is that there are distinctions in, so those blue circles, these are sherds taken from Zunhangai. There's a lot of overlap between sherds from Hanui Valley and Soyo. I actually find a simpler scatter plot of 2 elements, silica and alumina, to capture a lot of this variability more simply, the principal components. And again, we see this difference in, these are Zunhangai sherds, and the Soyo and Hanui Valley sherds overlapping next to each other, but still sort of in a similar framework to one another. And I'll map that out. These graphs show the mean and sort of confidence intervals of the concentrations of alumina in these 3 regions, which is distinct. Again, overlap in Hanui Valley and Soyo, and a really distinct signature at Zunhangai. So this is a part of this, the sort of next step that I'm working on, which is tying these signatures to the actual geology of the region. So these are the 3 sites, Zunhangai here, Soyo, and the Hanui Valley. They're about equidistant, which is interesting. And actually the geology sort of on a sort of preliminary level is fairly distinct from all 3 of those. So it's very interesting that we have much more overlap with the sherds from Soyo and Hanui Valley than from those from Zunhangai. Right? So that's sort of an interesting characteristic and something that we're continuing to work on right now, right? To really try and tie where people are using their resources, where clay sources are coming from. So again, the distances between regions are roughly equivalent. It's not that 2 places are very close to each other and therefore we should have similar geologic signatures. And in fact, the geology is so different. So the question is, what are people doing? Why is it that we see these similarities in the ceramics there? Maybe people living at Soyo and Hanui Valley are using similar types of resources, and people at Zunhangai are doing something very different. I don't know, but this is a question that this type of research can continue to answer. Now, seasonal differences in ceramic composition. So I focused this work on the Hanui Valley in the sites that Jean-Luc had identified as winter and summer occupied sites. Again, this principal components analysis, which is messy. And I'm just going to scroll through this because the answer is it doesn't really show us a whole lot. It's very mixed. There's a lot of overlap. There's not the sort of clear distinction we might expect to see if people are using different clay sources or different, sort of moving differently on the landscape in summer camps as they are in sort of the winter time. When you break it down, there are a couple of differences at these sites. So there is Here, this is the SP32E SHA site. That's the summer site. At least in the Bronze Age, there's seemingly higher levels of these two elements at those sites, or sort of a wider spread of ceramics there. So maybe there's some sort of differences in the range of places people are getting clays from at these two sites. Something more interesting is here rubidium and phosphorus, where we see larger gaps at this same summer site through time between Bronze Age and Xiongnu ceramic populations. Maybe changes in landscape use are different at summer camps versus winter camps during this time. So through time, sort of we see much sort of more dramatic shifts in how people are using the landscape in certain parts of the year and not in others. That might be what's happening. Again, additional research will really help parse this stuff out. So what I can say at this point about seasonal differences in the ceramic composition of sherds is that it's complicated. We definitely need far more than 3 sites to be able to look at this. It would also be really good to get samples of sites from much farther distant regions, right? For the Hanoi Valley, these winter and summer sites are essentially across a river from each other. Temporal changes in resource use might be more dramatic at certain parts of the year than at others, right? So the kinds of constraints and needs of people who have animals versus who are hunting or following animals could be different at these times, and therefore we would see this sort of that pattern reflected in the composition of sherds. Finally, it would be really interesting if actually there is similarity in summer and winter composition of sherds. So one thing that might be going on is people are just making pots in the summer, carrying them around all year. This goes counter to what a lot of people think. They say pots are delicate, they might break. Why would you carry them with you? But if you can't make pots in the winter, you might have to do that. So we could see this sort of really long-distance planning in artifact production and maintenance throughout the year. It would be really great to compare the sources and types of materials at these sites in terms of ceramics as well as lithics. It'd be neat to see what that looks like as well. All right, the temporal differences, my final set of results. So this is the material from Soyo. I compared sherds based on period using a Kruskal-Wallis test, which is a non-parametric ANOVA test with a correction. And all of this to say that there are significant differences through time that are detectable in different element types. And I think it's easier to look at it this way. So if we have sort of a progression from Neolithic, pre-Bronze Age, early and middle Bronze Age, and late Bronze Age, which are sort of how we attribute these sherds. There is an increase in the early and middle Bronze Age period of copper and rubidium in sherds, a decrease by the late Bronze Age in copper, increases again in rubidium and zirconium, and then a large number of decreases as well in late Bronze Age, telling us generally, it doesn't necessarily matter what elements are changing, but that there's a lot more change happening towards the end of the late Bronze Age, sort of the end of this period, and that perhaps that's telling us that there are more rapid changes in the way that people are moving around using new resources for making their pottery. So this is really promising in thinking about possibly a shift from one subsistence strategy to another, or one way of moving around the landscape to another. So in some ways, we see some elements remaining similar through time. So the main types of clay that are being used for these pots is staying the same. So alumina and silica forms about 70% of the composition of these sherds, and those concentrations are remaining pretty stable, meaning that people are using the same types of materials, right? They look for clay that behaves a certain way, but we do see big changes in the sort of minor constituents of the clay paste, suggesting again that people are going for clays that feel a particular way, have a certain moldability, but are from different sources, right? So these minor elements are more related to sort of variations in topography and geology. So that is exceptionally promising for thinking about change through time at single sites. So that we can identify changes in composition of pottery left at the same site through time. Again, maybe this reflection of a new kind of resource use, new types of mobility or movement on the landscape. But the overall strategy, the overall potentially the sort of crafting practices are remaining stable through time. So the same people are looking for the same, generally speaking, types of raw materials. It just so happens that those new materials have slightly different origins. All right. So to wrap all of this information up, the first and foremost thing that I want to say is that it is possible to identify compositional differences in pottery using this technique in Mongolia on prehistoric pottery that we know very little about. These are very small sherds. I'm sure many of you are aware of this, but they're small like this. You can use material like that to get data at this scale. It's also a powerful tool to clarify patterns of resource use, landscape sort of movements, and even sort of regional interconnections through time. So in addition to sort of this typical package of seasonality markers like fauna, lithics, and seeds or pollen, adding ceramics to the arsenal offers another line of really important sort of comparative data there. So we can compare with other materials like lithics. It would be really interesting to see how sourcing in lithic material changes through time relative to sourcing in ceramic material. Do they co-vary, or are they distinct? And also it could complement sort of the physical traditional analyses of pottery, stylistic changes. So influence in style relative to influence in how people are moving around. Petrography and mineralogy. I know that a couple of people are starting to use digital microscope looking at ceramic paste. It would be great to overlay that type of data with this chemical analysis as well. And finally, it would be wonderful. The next real step is to integrate local, actually on-the-ground geology with these models, so that not only can we just talk abstractly about differences in composition, but we can actually say people seem to be using resources in northern lying regions versus southern lying regions. So it talks about sort of landscape preferences. So we might say in one period, people tend to be moving northward where there are X type of geological formations. And then we might see a change that relates to new places on the landscape. So not only does this tell us about sort of abstract changes, but ideally we'll be able to actually put these on maps and talk about preferences and orientations for resources on the landscape. So with that, I wanted to say thank you. Yes?
Sure. I'm curious, it sounds like this is a very new thing. One season now, maybe, or two?
Mm-hmm.
Do you have a plan? Like, are you going to go in concentric rings out from where you started, or are you going to try sampling totally different parts of Mongolia to get some idea?
So there's two sort of directions that this sampling should go on. On the one side, I've basically been telling anybody who has pottery in this, everyone who has pottery, please bring it to me or somebody else working on this, so I would like to create a database that people can access, so that everyone working in archaeology in this region can access that and say, oh, my data is different, it fits in here, how does it, so that open access. So that's the sort of archaeological side. The geologic side is something that we're trying to work out now. Ideally, when Julia's having this survey looking for lithic material, that in tandem we could have people collecting geologic samples and bringing that back to create these calibrations for this region specifically. And also so we have a general sense of where is clay seen on these places. Mm-hmm. Did you have another question with that?
Yeah, just a very quick one. I'm sorry, I know everybody has lots of questions. It's all fascinating. Is this a broad enough time period that you can factor climate change into it?
It would be very awesome. I mean, presumably people are using the same sources through time, and you know about it, you hear about it, and then so that you might continue to use initially something that was for ceramic production, for bricks or something. I mean, the ingredients are slightly different, but you absolutely can do this with really any sort of material culture at all. And your first question was, I'm sorry.
Relating, this sherd came from that clay quarry.
Right.
Or is the way clay prepared?
So there are a couple things that complicate that. One is that unlike lithics, ceramics are an additive material, so you have people mixing clays, sometimes aging clays, though maybe not if they're moving around a ton, but preparing it in different ways, adding tempers and such to it. So it can be hard to say specifically this clay comes from near that mountain over there, but we can talk about it in broader geological terms too. So that this is sort of an illitic clay, so it must come from an environment sort of like this or sort of like that. So even if we can't point our finger to a map and say that is expressly where it is, we could talk about environmental or the geological environments from where things come, which also has implications for the types of resources that are there, what else would be available, in sort of a more acidic landscape versus sort of a more basic landscape in sort of, yeah, yes.
So a suggestion I think it's in Houle. There was a site, Chandran, which had a big pottery production in my understanding. So it would be, I think, useful to look at that.
Yeah.
And there was the burial. I don't add to this, but the burial entirely looked like a craftsman buried together.
Oh, that's really interesting.
There's an actual pottery pound with nice deer and ornaments on them.
Oh, wow.
So you might want to look at that.
Oh, that would be
They're
really interesting to see
on that, and it's
to
not
the
very
variations through time.
It's hard to hold some of those Western islands. And the second, adding to what Chris said, historical period, of course, the use of clay for woody sculptures is a big thing, and it would be very wonderful to really know what is local
Right,
production.
absolutely.
We have Karakorum, right? This is 14th century. We have Septim Monastery, which is 17th century. So it would be wonderful to
It would be great.
kind of testify that there's a local production.
Absolutely.
From overseas or something.
Absolutely, and so that is something that would be great to have in a database like this, where you could have people with different sort of research orientations asking questions like that, but absolutely statuary versus ceramic vessels, are they using the same sources? Maybe there's a certain particular source that needs to be used for cooking pots or high temperature pots and certain color for figurines or something like that. But that would be fascinating and would be really good to add to this. Yeah, Jen.
So I'm really excited, obviously, about the lithic aspects of this and how it can inform your study, not just for the sourcing, but for the organizational information that you can get from the lithics. Changes in manufacture, use and discard patterns, and how that might, really tell us about important changes as changes in the economy happen. I'm really
Absolutely, and I think we sort of make pottery very fantastic and important in the past because it's important to archaeologists because that's really what remains. So we fetishize it a little bit, but the reality is there's a lot of clay in the landscape. And so the question of why would you walk 20 kilometers in the opposite direction from where you're going to pick up clay that's heavy and bulky and that you can get that way anyways, right? So by doing this, this also tells you something about where people need to be on the landscape and sort of setting up what's been called a taskscape of production there. All right. Yeah.
In one of my lifetimes, I am a potter, and have also studied building kilns. So I'm interested in firing, I'm interested in composition. So do you have evidence of different high firing versus low firing? Is it all terracotta? Do you have anything approaching stoneware?
Not until sort of the medieval periods, and that is a distinguishing factor. I mean, the early stuff is very low-fired, very crumbly, probably reaching temperatures of about 600 Celsius. So it's very low open bonfire kind of thing. And we've actually done some experiments on different types of fuel, so dung versus wood, sort of a pit versus an open bonfire, all of which produced successful pots, even though we sort of were nonchalant about it. Yeah.
Yeah, I mean, I've done a lot of firing like that. Firing, sawdust firing, grass firing.
Yeah.
So on. It's pottery. But as you say, it's very fragile.
Right.
But I'm also wondering about the process of firing, changing the compositions. Do you have any way of looking into that? Because it certainly changes the structural composition.
Right.
So you can't break down a fired pot and turn it back to clay again.
Right.
Because the crystalline structure has changed.
Right.
But I'm assuming also there must be some changes in the elements because of temperature.
Certainly not at the temperatures that are being fired. Really, as you say, the big differences are mineralogical, right? That you have these transition phases of sort of molecular structure shifting, but the atomic abundance is going to stay relatively the same throughout this. There's some minor changes, but for the most part, what you put in, you get out. It just reorganizes and shifts around in different ways. Yeah.
Thank you.
Yeah. Sorry.
Well, thank you very much for your presentation, and I think we really need this kind of pilot studies on ongoing archaeology. And also, I was wondering if you, well, considering the limitations of pXRF and the variation and complexity of compositions in pottery, did you try to address, like, I mean, if you shoot in one part of the ceramic pottery, you will end up just getting information on just the surface, right? So there might be additives like that in the case. So if you just, let's say you should be one additive, composition is like silica, right?
Right.
You end up just getting silica. So did you try to
Absolutely.
people try to like shoot from different angles, like different parts, yeah?
So most of the time I work in China. And so I've done a lot of this type of work on ceramics that we've collected and surveyed in China. And one of the things that I was interested in trying to deal with is exactly that problem, right? How do you know that you're not just zapping a giant iron inclusion that's just below the surface, you can't see it, but that impacts the reading? So I did a number of tests that look at the variability and the homogeneity of the ceramic paste and really what gets picked up by the machine. And it's pretty good. So when I do these 3 readings, I take them on random different surfaces of the sherd to try and account for that. I didn't do it with these ceramics, but in China I sand, or I grind away some of the surface to make sure there's no contamination. But I also found that that doesn't really impact the readings all that much. So I've done a lot of these things. You can also do sort of measure for variation in the machine ability to read. So you just zap the same spot for 10 times, look at the variation in the elemental abundance for that, and then you sort of can move the sherd around 10 times and see how variable that is. So that helps you identify things. So in China, there was definitely a problem of lead getting from the groundwater that was a post-depositional inclusion because it ducted to the iron. And so that was something that I then did not use in my analyses because that was post-depositional and not related to the actual clay itself. But yeah, all of those things are really important and have to be covered to be able to do this kind of thing. Absolutely.
What about glazes and things like that?
So the depth of penetration of these rays depends on the size of the atoms that are being sort of irradiated. So you can get very surface readings of like a glaze, but for some elements you'll sort of penetrate past the glaze. So it depends on how thick that is. But people do, they want to know what the glaze composition is and are not so much interested in the body of the sherd, and that's been done too. Yeah.
Or this is a lot of questions.
Yeah, it's fascinating. So do you only pick up the glaze composition, or do you actually get some residues of what kind of food was cooked in?
So that would be really neat if we could pick up the residue, but those are organic and those are things that just fly by the analysis. So it doesn't actually really pick up the readings of carbon, for example. It's just too light, too small. It just can't interact. So
Other ways to do that.
yeah, it would be neat if it was a one-stop shop and you could do all of that.
Just curious if that portable device, you said, to check the glazes versus what's inside. Can you set how deep it's going in?
No, that is standard. There's some ways to tweak it, different filters and stuff. But for the most part, it's just a factor of the intensity, like what gets activated by the intensity of this particular ray being used, yeah.